Howdy folks, we're going to talk about Chapter 7 today and classes. Let me start a new project here. I'm just going to call this week 6 because that's the week we're on. We mostly skipped over Chapter 6 because that's debugging and we've kind of been using the debugger throughout. So definitely a good chapter, but we don't need to spend a whole lot of time working on that here. So let's give it a look. So with classes now, we're kind of expanding our ability to solve problems, which is super cool. So classes are one of the fundamentals of object-oriented programming, and we're going to use them here on out. And we've actually kind of used some classes already without realizing a whole lot about it here. So we did this thing like scanner keyboard equals a new scanner given system.in. We were using a class. So the class is scanner. Right? This import class option says, hey, give me the scanner class from the Java utility library. So then we called it keyboard, and then when you say keyboard dot, you get access to all of the methods in that scanner class. And again, we're really only using next line. The other ones are interesting and all, but they usually cause problems for us. So next line's my favorite one, but there's other fun things you can do with it as well. So it gives you some functionality around this scanner class. So, and the idea with classes is that we're going to take all of the details, all of the implementation, and encapsulate it in one nice little package. So encapsulation is a common term you'll hear with object-oriented programming, and really that just means we're going to take all of the details, we're going to encapsulate it into one nice little package, and then what you're allowed to do is you're allowed to make things private that no one else has access to, and only give them access to public methods. So a lot of times this idea of encapsulation goes along with abstraction. And abstraction is a big funny word, but what that means is we deal with a public interface or an API, application programming interface. So there's public methods. So I say keyboard dot. These are the things that the scanner class tells me I can do. Right? These are the public methods I have access to. I don't know how scanner works, right? All the details around how the scanner actually gets input from the console, we have no clue, and really it doesn't matter to us. It's sort of a black box at that point, but we know I can ask it to do something and it will do that thing. So we get to work with it in an abstract manner. So classes are fantastic for encapsulating all those details, hiding away all the implementation, so that you just get to deal with what it actually does, the public method that it offers you. So when we talk about writing classes, we're going to encapsulate all of our details, and we're going to give a public methods or public interface for people to use our class. Right? Like when we talk about methods, one of the nice things about them is it allows for code reuse. Well, classes really takes that to the next level. You can build up these packages, and maybe someday you'll go work on the Java core library and you can add new libraries to Java. But most of the time, we can just write other packages that people can go and use, and they can just use our class, which is fantastic. So we can make code that's useful and other people can use it. So to make a class, now you might have seen we have the word class here. It's been in every one of our projects. We mostly have ignored it for now, but you'll notice the name of the class, main, matches the name of the file. So Java's rule is you get one public class per file. And for our purposes, we really only want public classes here. So if I want to add a new class, I'm going to come to my source package and say, hey, I want a new Java class. And then we can say, okay, let's call this one, how about chair? And we have a public class for chair. Now what we're going to do is we're going to have our list of attributes. So classes generally are nouns. They don't have to be, but most of the time they end up being nouns because talking about things in an object-oriented manner is very natural to how humans understand and interact with the world. So if I say chair, you sort of probably already have an idea of what a chair is, right? Because you know that now, and it might have legs, it might have wheels, it might have a seat, it might have a back, it might have arms, it might have a certain height. So those are all attributes of chair. So what we get to do here is I get to have a list of attributes. Now, our good encapsulation principles say these should all be private. So I'm going to say private string for color. That's the color of my chair. And a private string for, what do we want here? Actually, we don't even need a string. How about a Boolean for has arms? And then a private int for height in centimeters. Again, if you're specifying a unit, or if you're some measurement, you should always give the units. Because if I say height, I imagine probably a lot of you would think inches, but our imperial system is horrible. And why does it have 12 inches to a foot and 5,280 feet to a mile? And it just drives me nuts. So I much prefer the metric system simply because it's base 10, right? There's 100 centimeters in a meter, there's 1,000 meters in a kilometer, those sort of things. The base 10 just computes a whole lot more easily for us. So If we do a height in centimeters, I can tell you how many centimeters high my chair is, whether or not it has arms, true or false, and then the string for the color here. So these are private attributes then. So if they're private, no one will have access to them. So if I come over to my main class here, I can say, I want a chair, and I'm going to call it, this is Eric's chair, and then equals a new chair. So this new keyword is used to create an instance of chair. And what that means is it loads a new chair into memory. So all of these attributes of chair have to get loaded into memory. So Java asks your operating system, hey, I need a place to store a string for color, I need a place to store a Boolean, and I need a place to store an integer. Now, if I say Eric's chair dot, I don't get, there are actually a couple things here, which, we'll get to in the next chapter, but none of these things are what we wrote. So essentially, there's not a whole lot of functionality here. But what we can do now is I can start writing public methods. So I can say public string get color, and it will return the color. And I can say public void set color, given a string for color. And I can say, now this gets a little bit funny here. So you notice this color is purple here, and this color is kind of gray. So if I say color equals color, we get some trouble here. And it's telling me, right, we reassigned the color here. So if I want my private attribute of color, I say this dot color. So this means the current instance here. Notice now they both turn purple. So I get the purple version here, which is really nice. So the white is the argument, and the purple is the private instance variable. So this color means this instances of chair color, and then the color that you give me. So sets and get methods, or accessor and mutator methods, are the common way of interacting with these attributes. So you don't need to know behind the scenes what I have, but you get the public methods for set and get color. So you can set the color of the chair, you can get the color of the chair. Now when I say Eric's chair dot, I see I have a get color and a set color. So I can set the color of my chair to black, not block, black here, and then I can get the color. So if I were to print something out, I could say Eric's chair is color, Eric's chair color is, and then I would say Eric's chair dot get color. So we use this dot notation, just like we did with keyboard with the scanner object. It was keyboard dot, so now it's our instance, our variable name of this class dot, and here's the method I wrote, so I can get the color back out. Again, it's not very interesting here because I know it's just black, right? We just set it to black here. But we can do that. So we say Eric's chair color is black, and then, oh, I never got rid of the hello world. We can get rid of that. Okay, so you write these set and get methods for our attributes. Now, I'm not a big fan of doing things by hand that I don't need to. So what you can do is you can click this generate button here, and you can generate getter and setter. And you can say, okay, I want, now this you can't, there's no like checkboxes here, so you need to control click or shift click. So control click lets you do more than one at a time, or top all the way down to the bottom, right? Or you can, so any way you want to select those is fine. Now, has arms is a little bit funny here, because Booleans don't have sets and gets, they have is, right? It's not a get. So I'm just going to change that one to has arms, and I'll just return has arms. So it's a little bit funny, but that's okay. And then set has arms takes a Boolean for has arms, and we'll set this has arms to the has arms argument. So you tell me true or false, and I'll set that. So my chair, yes, has arms, and then a get height in centimeters and a set height in centimeters. So by convention, most of our get and set methods will be get or set, and then the name of the attribute. Again, Booleans are a little funny here. Don't worry too much about it. But you tell me the height in centimeters, I'll set this height in centimeters here. Now what's fun about that here, so I can set the color, I can take Eric's chair dot set has arms to true, true, there we go, and we can take Eric's chair dot set height in centimeters, and I don't actually know how tall this is, so I'm just going to say 30 centimeters because I don't want to measure right now. Now you might think we haven't really gained a whole lot here, and that's true, we haven't really done a lot yet, but what I can do now is I can make another chair, and I can have my son Jeb's chair is a new chair. So now what's going to happen in memory, there is going to be my chair with its own set of attributes, and then it'll be Jeb's chair with his own set of attributes. So what we're doing now is I can have multiple instances of this class loaded in memory. So I can assign a chair for each member of my family, and I don't need to have 3 attributes for each one of them. Right? We could have Eric's chair color, Eric's chair has arms, and Eric's chair height in centimeters. We could keep all those attributes separate if we wanted. But what this lets me do is encapsulate them together, group them all together into one nice object. And we're used to referring to objects, right? This is sort of natural to how humans talk. So code is for people. writing object-oriented code makes things easier for people to understand because it just sort of works. And let's see, let's get some more attributes here. So I'm going to say Jeb's chair, and Jeb's chair. So Jeb's chair is gray. It does not have arms, so I'll say that's false. And I think the height's probably 30 meters. Yeah, it looks about the same height as mine. So we'll say 30 centimeters again. And then if we wanted, we could go and print all these things out again. So Eric's chair has arms is going to be has arms. And then the height in centimeters, Eric's chair height in cm, height GHT, I can't spell, get height in centimeters, great. And then to do that with Jeb's chair, I'm just going to copy paste this, and then I'll throw in Jeb a couple times, Jeb, and then Jeb's chair over here, Jeb's chair over here, and Jeb's chair over here. So I can run it, and I can see I now should have an Eric's chair with my details and Jeb's chair with details. But if I wanted to run it in debug mode, this is where it gets fun, so I can put a breakpoint in here and run with the debugger. I can see these variables in memory, just like we could with the other values, but now it says, hey, it's a chair. And now if you expand it, you can see, oh, here's the color attribute, here's the has arms attribute, and here's the height in centimeters attribute. And then if I want to step, right, to step over, now I'm going to step into Jeb's chair, and now we have a Jeb's chair in memory. Now, by default, color is null. Null is really ugly and dangerous. We'll talk about that later, but just keep that in your back pocket. Before you set something, it's null. Has arms is false, and height in centimeters is 0. So values that are primitives will default. But remember, string is not a primitive type. String is actually a Java class itself. That's why we can do things like equal ignore case and all those fun things with strings, because that's a class, right? The Boolean and integers don't do that. So if I were to type like has arms dot, there's nothing here for me to do. I mean, these sort of look like things, but they're not actual options here. Or height in centimeters dot. There's no real options for me to do anything here. But string, or the color now, I get a bunch of things. I can set, I can check things, because it's a class. You have access to all of the methods of the string class. Okay, so that's our basic chair. But now, this is kind of tedious to have to print all these details out here, right? So what we could do then is I could, anytime you have the same code twice, we feel bad about ourselves. I'm going to take all of that and cut it here, and I'm going to make a new method. I'm going to make a public static void print chair details. I'm going to say, if you give me a chair, I'm going to call chair, and then probably the string for the owner's name or something. Then I can print out, now it's owner's chair, owner's names, plus the chair here. Right, so the owner's name, and then chair dot get color, get has arms, and get height. So I can give an object, give an instance of a class as an argument to a method, and the method can then use those public methods of that class. So I can say, okay, here's a chair, go get the color, get the arm, whether it has arms, and get the height in centimeters. So I can print these chair details now much more easily. Print chair details for Jeb's chair, and that's Jeb is the owner here, and I can do the same for Eric's chair. Right, so this will be Eric's chair, and owner's name is Eric. And then we don't need to have this repeated code here, right? We can have a nice name to what's happening, and then we can avoid the repeated code. So we give it a run, stop and run, and we get our details here, just like before, right? But now we're passing that chair as an argument, which is super handy, because now I can take an entire object with all of its attributes and pass one argument. If I were to do this before, we would have had to pass the chair color, and pass the chair has arms Boolean, and pass the chair height in centimeters as 3 separate arguments, which we could have done, but now we're able to talk about it as, is that even spelled right? I swear it looks like it's spelled wrong now. Chair. I don't know how to spell chair. It looks so wrong now that we've done that so many times. Let me just make sure. Chair. Yeah. Okay. It looked really weird to me for a second there. So you can take all those details, group them together, and talk about them as an object and add those public methods, which is super cool. And then the next thing we can do is we can actually start interacting with the chair in other ways. So there's not a whole lot of interesting things that I could do right now, but if I were an adjustable chair, we could change the height. So maybe something that we need to know here, then maybe we have a private int for minimum height in centimeters, and a private int maximum height in centimeters here. So we need to go set and get these values. So again, don't write the code yourself. I mean, you're welcome to do it here, but I'm gonna let the tool generate it for me. Generate getters and setters for, now it has the has arms again because it doesn't recognize that convention because I changed it to has arms instead of is has arms. It's okay. Don't worry too much about it. But now I can get and set the maximum height and the minimum height here. Fantastic. So I can make my chair and I can say, okay, I have the current height in centimeters, and then we'll set the, oops, sorry, set minimum height in centimeters, we'll say is like 20, and then how about we take Eric's chair, set the maximum height in centimeters, say 40, because I don't actually know what it is now, but that's okay. We'll say min is 20, max is 40. So I can go up and down 10, up to 20 centimeters total, and I'm going to start in the middle. Now, that doesn't do a whole lot for me, but now I can go and interact with it, which is super fun. So I can add another method here. So I don't need another attribute. I just need a method here that will go and change my height in centimeters here. So I can say public void raise chair, given an int centimeters to raise, and I'll take my height in centimeters. I'm going to add to it the centimeters to raise, but then I need to make sure I didn't go over the max, right? So I can check, hey, if my height in centimeters is greater than the max height in centimeters, well, let's just pretend that didn't happen, and then we'll set it to the max, right? So if you went over the max, we'll just pretend it never happened, and we'll change it back to the max here, right? So you can raise the chair a certain number of centimeters, and I can do a public void lower chair, given an int centimeters. Now, this is sort of silly at this point here, so I'm actually going to avoid all of that here. And I'm going to say, how about instead of raise chair, how about adjust chair height? And then we'll say this is the centimeters to adjust. So I can, if this is a negative value, it will go down. If it's a positive value, it will go up. So I'm going to check if I went over the max. I'm going to check if it didn't go over the max. Let's check if it went under the min here. Oops. If it is less than the minimum height in centimeters. And if we're less than the minimum, right, if we went under the max, well, that's no good. You can't do that. Let's reset to the minimum. Okay, so we will add the centimeters to adjust, whether or not it's a positive or negative number, and then we'll check, did we go over the max? Okay, reset to max. Do we go under the minimum? Okay, reset to the minimum. So I can interact with the chair now. Right? I can say Eric's chair dot adjust chair height. I can go up 5 centimeters. Right? And then we'll print the chair details, and then maybe we adjust it, how about like negative 10 centimeters to adjust it there again, and then let's try it again. Let's just go nuts here and do 100. It should stop at the max of 40, and then one more time we'll go nuts here, and we'll say, okay, how about negative 100? Let's make sure I can't go below 20. So again, we're just kind of going to eyeball it here. So we have Eric's chair, starts off at 35. Does that seem right? So we started at 30, and we adjusted at 5. We're at 35. We took away 10, we're down to 25. We added 100, capped me at 40. We took away 100, it limited me at 20, right? So our class now has logic that protects the integrity of the class. This is why this is super cool, because we can go and adjust these. So we actually probably want to get rid of the set height in centimeters and forget that. We probably don't want that to happen here. And say, nope, you don't need to set that height in centimeters here, because I don't want you interacting with it directly. Because if you call set height in centimeters, you can go set it to anything you want, right? Because set directly just said, okay, sure, I would just take this value. Not ideal here. So instead of setting the height in centimeters, right, we would adjust the chair. We'd set a minimum, set a maximum here, and then we could adjust. If I adjust 5, well, it will go to at least 20 if we're under the minimum here. Right, so if I run it, now we're going to start at, now we got to get rid of the Jeb's chair height here. There we go. Try that one more time. There we go. So we go to 20, and then we try and subtract from 20. You can't do it. You can't go any lower than 20. We can add 100. We stop at 40. You take away 100. You go back down to 20. You hit the maxes again. So we can add some protection to our class to make sure it has integrity. The idea with class code encapsulating all the details means that we can write the code to ensure that our class is never in a bad state. We don't want to allow that height to be lower than the minimum or above the maximum. Right? That's just no good here. That's not anything we want to have happen. Okay? So I think we're in pretty good shape here so far. So why don't we end it now, and then we'll take a look at some other features of classes here in a little bit.